Good morning, children. Welcome to Bharat Mata Google Classroom. In the last class, we discussed about the discoveries of several scientists, starting from Sir Humphrey Davy to William Crookes. So today we are going to see the experiments and findings of certain other scientists. Eugen Goldstein. He was a scientist who recognized or discovered the presence of positive charge in gases by conducting the discharge tube experiments. So in 1886, he carried out experiments in the discharge tube and he found the presence of positive charge. So Goldstein used a cathode ray tube in which the cathode was perforated or it had holes in it. Okay. In 1886, Goldstein noted that the cathode ray tubes with perforated cathode emits a glow from the end of the tube near the cathode. That is, he found that in addition to the cathode rays that travel from negatively charged cathode towards the positively charged anode, there is another ray that travels in the opposite direction, that is from anode towards the cathode. Okay, so earlier we learned that cathode rays travel from cathode towards the anode, but now he found that anode rays travel from the anode towards the cathode. Because these rays pass through the holes in the cathode, he named them canal rays. You can find that it passes through the holes in the cathode, so he named them canal rays, or they are called as anode rays. He also concluded that these rays are positively charged particles by studying the features of the anode rays. Because it travels from anode to cathode, it is positively charged. Now coming to Wilhelm Röntgen. So in 1895, Röntgen, he placed a black paper in the path of the cathode rays and he found a green colored fluorescent light being emitted from the screen which was placed a few feet away from the cathode ray tube. So he realized that he produced an unknown ray and he named it the X-ray. Okay, and through many additional experiments, he found that this new ray would pass through most substances, casting shadows of solid objects on pieces of film. Actually, he found these rays accidentally, and he took the X-ray of his wife's hand and he found that the X-ray film revealed the bones and the ring on the finger of his wife, and this led to the conclusion that the X-rays would pass through tissues of human beings, leaving the bones visible. Okay, so X-rays can pass through tissues, it can pierce through certain materials and it can cast shadows of metal objects or bones is on the film. So it is very useful, and it is even now it is used in medical science is to treat a fractured bone. We use X-ray. Again, in industry and in construction field, we use these X-rays to find out the flaws or the cracks in the buildings or the cracks in the metals used for construction. So it's very, very useful. We can find out the minute cracks in the buildings or in the construction. Next, coming to J.J. Thompson. So he conducted experiments which proved that on electric discharge, the rays originating from cathode were negatively charged particles. And he also proved that these particles were common to all the substances irrespective of their nature. That is, if you are going to take oxygen gas or neon gas or hydrogen gas in the discharge tube, all these gases will give the same negative charged particles. Yes, and he proved that these particles were common to atoms of all the substances. And he also proved that these particles are smaller than the atom and it is part of all the atoms. Okay, he termed it as electron, and he also proved that electron has mass and energy. Now take a look at the picture. This is the experiment he carried out using cathode ray tube, and he proved that the negatively charged particle was electron. So we learn about a few more scientists in the next session.